Listed below, actually to the left, are systolic blood pressure measurements obtained from the same woman in the regression equation, or find the regression equation. Letting the right arm blood pressure be the x variable and the left arm being the y variable. Now what we want to do is find the best predicted systolic blood pressure in the left arm, given that the systolic blood pressure in the right arm is 80 millimeters of mercury. Okay, and we're going to use a significance level of 0.05. Now, before we could even answer this question, we have to determine if there is a correlation. So, but let's talk about this specifically, this keyword right here, predicted. All right, so we can determine the correlation coefficient, and we could plot those on a scatter plot, and using Excel, we could quickly find the regression equation. So let's do that. I'm going to insert, so we'll highlight the data. We'll go to insert. It's a very simple process, just one click. Click on the little icon of the graph that you want to insert. We want a scatter plot, so we'll click on the little scatter plot icon, and there we go. Now, we can make a few edits if you want. It's not necessary, but this name of the chart should not be left arm. We could call it blood pressure. Ooh. We could call it blood pressure. And we could add axis titles if you want, but that's not really necessary for this problem. But we see these 5 points. Each point is one line of this chart, or one ordered pair. And if we wanted to insert or come up with the regression equation, remember the regression equation, also called the predictor equation, is what we use to take data that we have already and use this data to make this model, or this equation. So straight line, so there's the equation y equals mx plus b. And then we could use that equation to predict something that hasn't happened yet. For example, we want to predict the blood pressure in the left arm, given that the right arm is 80. Now, the only way, and this is important, the only way that we can use that equation to make any predictions is if the relationship or the correlation is strong enough. So let's go ahead and come up with that regression equation. If you're doing this by hand with a calculator, the formulas are pretty involved, but we're just going to use Excel. So you could click on one of these points, doesn't matter which one. So you click on one, you see all 5 points are highlighted. And then a right click brings up this menu, and add trend line. Remember, in statistics, we call it a regression equation or a regression line. Excel is not a statistics program, so sometimes the terms are different. In statistics, it's called a trend line. All right, so we'll add the trend line, and we want the equation. We want the regression equation, so we have to click this little box right here at the bottom, display equation on chart. If you see where my mouse is, display equation on chart. Click on that guy, and there's our regression equation. Now, if you want, you can, it's a little condensed here. We have a lot of open space in this graph. Again, this is not necessary for the problem, but if you want to format, let me select the x-axis, for example. If I instead of going from 0 to 120, what if we started at around 70? So if you select the axis you want to format and click Format Axis, you'll see it goes 0 to 120 here. We could change that 0 to, like I said, maybe a 75. All right, so we basically just zoomed in on the part of the graph we want. And let me move this regression equation. There's the regression equation. We can make it a little bigger. Okay, so basically you could use this equation, plug in a number for x, and you figure out the value for y. And so in this case, if we could use this regression equation, and we don't know that yet, but if we could use this, we take the 80 and we plug it in for x. So now the question is, can we use this regression equation? Well, we have to first determine is there a relationship? Is there a correlation between these two sets? All right, so we need to calculate the correlation coefficient. And the Excel function for that is equal CORREL. So the name of the function is CORREL, coral, for correlation. And then in parentheses, the location of the data. And we have two sets, so we have to highlight the first set, comma, highlight the second set, and just take a look at that Excel function before I hit enter. That's what it should look like. Now, there's our correlation, about 0.82. Now, for a large data set, that would be a pretty strong correlation, but we have a very small data set here. We only have 5 pairs of numbers. So we are using a significance level of 0.05. So this is our table of critical values for the correlation coefficient. Saying use a significance level of 0.05 just means use the column that's labeled 0.05. So we don't need this guy over here on the right. And now n is the number of pairs of data. So in this problem, n is equal to 5. We have 5 pairs of data, so we'll go to the row where n is equal to 5. So here's the row with n is equal to 5. And it looks like our critical value is 0.878. So our correlation is not strong enough. Our correlation, which is right here, so R is equal, and if we round this, we'll say 0.822. So our correlation coefficient in this case is not large enough. It doesn't go beyond the critical value. So the critical value is the cutoff point. This is the lowest possible value for your correlation coefficient. So you always want to compare your correlation coefficient with the correct critical value. And so if the correlation coefficient is bigger, then you say, yes, there's a relationship, and we could use this regression equation. If not, if the correlation coefficient is not big enough, then we cannot use that equation. Then the best predicted value. And that's what we're looking for here. Find the best predicted value. That's not going to be the y in this equation because we can't use this equation. The best predicted value will be, let me switch to a different color. The best predicted value will be equal to the average of the y values. We cannot use the correlation, well, the correlation coefficient was too small, so we cannot use the regression equation. So instead of plugging in 80 for x, which is what we would do, we just use the average of the y values. So I'm going to put the answer down here. Down here, we'll make this yellow so it really pops. Okay, so the answer to the question, equal average, parentheses, average of the y values. So in this case, because the correlation coefficient was too low, the best predicted y value, or the left arm systolic blood pressure, would be the average of the left arm values that we already know, which in this case, 157.8. All right, that does it for this video. I hope it was helpful.